Those questions we will try to answer. So I'm sharing my screen now. I hope my screen is visible to all.
Yes, sir.
Yeah. So basically now, if we try to answer this question, like what are the prerequisites if you want to learn chaos engineering? First of all, a little bit of testing experience is always good, because chaos engineering is more sort of a domain where if you have a good development knowledge, it's always a plus point. But also you should know the mentality of a tester. Okay, so it's more sort of a test engineer, right? Like how he thinks and how you find out the issues in your system. That is very critical when you speak about chaos engineering. So that mentality, that psychology of a tester is very important, or a test engineer, I can say. So that's one thing. But rest is like the coding knowledge and all is not much required as such, because the tools which we use. But the main thing is the architectural knowledge, like the application which you are working. Like for example, uh, whichever application you're working, like if it's a Kubernetes based application, or or you have some on-premise, off-premise applications, microservices based applications. So you need to know what are these applications in and out well to become a proper chaos engineer. Okay, so that's what this course also covers overall about. So it tries to cover um, the the main principles behind a chaos engineer, and what a real chaos engineer responsibilities and activities he performs, that we try to put it in the syllabus. Like for example, what all works and what all type of tests he need to execute, because you might find lot of materials online, but you will never find something which is step by step, or we can say an end to end, from what a chaos engineering is, and to the last, by running a test execution analysis in that way. Okay, so you won't find a course which is very detailed in an end to end format from starting to the end. So next is like we will be focusing, if we see about the tool, right? Tools mainly, there are a lot of tools available in market nowadays for chaos engineering, and the main tool which is a leader of the industry currently is Gremlin. Okay, so we'll be extensively seeing Gremlin, like installation on different systems, like for example Kubernetes, Dockers, how you containerize your Gremlin. Then how, so when we learn this, like for example when we learn how to use Gremlin with Kubernetes, we will be going through some basics of Kubernetes also, because there will be wide range of audience, right? So we need to know like what are these, right? Kubernetes, Dockers, containers. So in a nutshell, you will learn those new generation technologies also, like what are they, though not that deep into what it is, but at least you will be able to know, like what these are and what are these applications used for, how are these applications used for in the real time. You'll be able to see, like you'll be able to see it, right, when we're doing the practicals. uh, then we will be also seeing like how you generally design, plan, and manage the chaos experiments. We generally in chaos engineering, we never say a chaos test. Okay, it's always a chaos experiment. So we will be seeing why we are calling it an experiment in the course as we progress. But for now, so we will try to learn that. Okay, like how do you design, plan, manage, and run these chaos experiments, and how you add value. See, ultimately, whatever you do, it's a return on investment which your client is interested in. Now for example, chaos engineering, now he might ask this question, right? Why do we need like one more testing? We have already security testing, performance, we have automation, lot of testings are available already. Why we need to add one more chaos engineering activity in our project? So ultimately the question comes to ROI, right? The return on investment what you give. So ultimately it's the question, so you need to answer that. Okay, like how you can add value using questioning. So these doubts will be clear. Okay, once this course ends, you will be able to answer these questions clearly, like how to the stakeholders, how I can sell chaos engineering, and how I can build up a whole team of chaos engineering, and how I can like let's say inculcate chaos engineering activity into the process of the total pipeline, or we can say the total project. Like for example, nowadays if you have development testing, then we have performance engineering, then we have, let's say, it goes to the production, right? But in between this, let's say you want to add chaos engineering activity also as a standard process. So that how you will be able to do, okay, what are the ways to do that, that also you will be learning. Then automation is now a keyword everyone is using. Like people are going for reducing the manual efforts as much as possible in every field. Okay, there is no field which is not looking for automation. Every field, and the leader in that field is Jenkins. Okay, so we need to know how we automate our chaos experiments using Jenkins. So that also we will be learning. So in a nutshell, if you see the course, one is like you will learn a lot from chaos engineering and the tools like Gremlin. Second, you'll also learn a lot of new generation methodologies, tools like Kubernetes, Dockers, containers, Jenkins, right? Because people are using Jenkins, but they are not aware like how generally a pipeline is created, how a stage is created in Jenkins. Okay, so those things will be clearly covered in this course. Okay, also Kubernetes. You would have heard a lot of Kubernetes, but what is Kubernetes? What's a control plane? What's a kubelet? What's a kube config? Different components inside a Kubernetes. What's a managed Kubernetes and what is the generic Kubernetes? So all those questions also will be answered and discussed in the class. So those like those areas will also be covered, okay, which you will get extra knowledge in. And again, so who can enroll in this course? So again, the testers, engineers. So no, the main prerequisites is just that mentality of a tester and that maturity. That's all. The rest is like uh, you can learn from the course and build up. But the development knowledge is always useful if you want to go to an SRE path, because an SRE is more sort of a chaos engineer with a good development background. So if you want to go to the SRE path, so you should know, at least you should have a good knowledge in one of the languages, some Python or some backend languages and a front end language with chaos engineering. So this way you can, that's why this title, a leap towards the role of a system reliability engineer, because uh, a SRE will surely know chaos engineering. Okay, without that, no, a person cannot go for reliability engineering. So this is a prerequisite. The chaos engineering is a prerequisite to become an SRE. And also a development background is always preferable because they are very close to the development environment. So that's why, and the production environment. So that's why it's critical, like it's always preferable to have a development background, right? Now, if we see the course syllabus, okay, now in little more detail, step by step. So first we start with the introduction. So introduction, we cover some chaos engineering introduction, then principles, then some prerequisites, some limitations of chaos engineering, and then uh, we will do some practical hands-on with the tools what we have. Okay, like how you break a system, how you plan your first experiment, then injecting chaos into CPU and all those. Okay, then as you progress. Like you understand first of all how you bring chaos engineering into action, right? So there we will be speaking about chaos engineering, like who are the beneficiaries of chaos and how you apply it to your organization. Some game day experiments we will see, what's a game day, then planning and managing, and we will see a little bit on the tool called chaos toolkit. Okay, so basically in this course we'll be covering two tools. Okay, Gremlin is very extensively we will be covering because it's the leader in chaos engineering and it's leading the market. Then see, if some projects, okay, some clients they ask for, okay, Gremlin is a paid tool. So why should we go with, let's use some open source tool? But there will be questions like open source tools are not that it's not in a very mature stage at this time, because the most common, or we can say mostly used open source tool, which is chaos toolkit and chaos blade, these two tools are not that old. Like if you see, it's around 2 to 4 years only. Okay, and the community is also very small for these tools. So that's why applying it to a project is a questionable thing, though it's an open source. So that's why people will go with Gremlin a lot, the projects also, because and also their licensing is also very flexible as per the size and all. So generally people go with it, Gremlin, but we will cover chaos toolkit also, so that we are we have one open source tool and one paid tool. Okay, Then monitoring and capturing metrics, like what are metrics are important as a chaos engineer, what are the KPIs which you are looking for as a chaos engineer, okay? Because we can say, okay, all in terms of reliability and all, but what are those metrics, right, which show this reliability of your system? Like for example, what are those values which I need to give to my client or to my stakeholders to improve the system? So what are those metrics? We need to understand what we need to monitor, what all we need to instrument as an application, okay? So those things we will try to learn. Then gremlin, obviously we will be seeing extensively, like what are the different types of attacks in gremlin, how you run an attack, what are the how you create a scenario, schedule a scenario, then how you run a game day in gremlin, how you install gremlin, or we can say implement gremlin into kubernetes containers. So all those things we will be covering, okay? So we will be seeing containers and dockers basics, kubernetes basics, okay? Like what are these kubernetes, and what are the important components inside a kubernetes which we need to take care, and how do you analyze, right? For example, if you are running some experiments in kubernetes, so what all metrics you need to collect, how you collect, like how you go into the system, what all commands you need to run to analyze those systems, okay? That we will try to cover. Then we will be covering some injecting chaos in database, or how what all different attacks are there for different applications. Then automation we will be covering, like we'll be seeing how you can use automation for chaos, like for example, how you implement gremlin into the CI/CD pipeline, right? For that, what all you need to know, you need to know like what's a Jenkins, like how generally the Jenkins works, some basics regarding Jenkins, and how you can implement Jenkins pipeline, okay? Like what's a simple pipeline code, okay? So those things we will be seeing, like we'll try to cover little in depth. So, and we will be speaking about, like in this section only, about shifting chaos to the left, what are those, and how you generally do that. Then some future scope, like how generally chaos engineering will help in your career, and we will also complete the certification of gremlin at the end of the course, so that everyone has that certificate to showcase that they have completed the Gremlin certification. Isha certification will be different. That's given to all who. It's a different thing. But what the certification which I am saying is a Gremlin certification. Okay. Some people would have done it already. That's fine. But if someone has not done, we will be covering that also. Right.
So, sir,
So
is it a
coming,
paid one? How much do we need to pay for the Gremlin certification?
it's a free certification. But only thing
Okay.
is there are 3 attempts to it, I guess. You need to complete it, and there is no, if I remember properly, you cannot, uh, but it's easy only, we can cover it in the course itself, you will be clearing it, not an issue. But it's a certification provided by Gremlin organization themselves, so it's a free, it's not paid for now.
Okay, sir.
Yeah. So let's come to our chaos engineering, okay? So I'll be sharing lot of materials also, and I keep updating those materials in the drive also with the latest updates, if any, because have, like we are active participants in the Gremlin communities and all, also with the Gremlin organization, because if you see, they have provided me with the uh, like organizational free trial, okay? Because we are taking this like we are very active in this field, okay? So they give us the industry license free of cost. So that's why, so that can be utilized by you all also, by those materials, because those materials, if they reach others, it will take time, but to us it reaches little early. So that way it will be very much useful for you. I keep updating this drive. I'll share this link with all once you formally join the course. Yeah. So this is a module one, which is introduction. So any queries, anyone? I can answer any query regarding what all I said till now.
Vishnu, do you have any weekend classes or this is just a regular day to day?
Sorry. Like, how? What do you?
No, no. Do we have any weekends like Saturday, Sunday classes, or this is just only weekdays and regular
Yeah, so
classes?
basically it's a weekday class. But if people are okay, I can convert it to weekend class also. Not
No,
a problem. Like
I am working from EST time zone, so
okay,
this is like a half day, mid of the day for me.
okay.
And yeah, so that I'm asking for any if you have any
Yeah,
weekends.
so if
Same
like
is with
okay
me,
for all.
Vishnu sir, because I'm also
Yeah.
working in EST time zone. Yeah.
Okay. What about Moses and Shahenshah, Saundarya? Like if I say, if let's say I
I work
yeah.
EST hours, Vishnu.
Okay, okay. So what if I take some Saturday class for some 8 hours and all? I
Oh my
means
God.
like how it will be. Yeah. Or 4 hours, let's say.
Um, yeah, I think it will be okay, but is it okay that you start little bit early on Saturdays instead of
So
waiting until
early, yeah,
10 a.m. EST, or instead of that, like
yeah, yeah.
maybe
So
5 or
correct.
I mean 6 or 7 a.m. if everybody is okay with it.
Yeah. So basically now your time, if we see Saturday,
Mhm.
so it will be our maybe afternoon, right? Around. So 6 means it will be
Yeah,
11
if
for
it
you.
is 7 a.m., it will be 5:30 p.m., right? 7 a.m. EST means 5:30 p.m. IST for you.
Sir, if we can, uh, if we can have in the morning, actually, IST morning time, whenever you're feasible over the weekend. For example, 7:30
Yeah.
or
So
8 a.m. if you're available,
okay. Mhm.
and it
Let's
will be
say
night
let's
here.
okay. Let's say if we keep 9 a.m. or yeah around let's say 9 a.m. Okay.
Yeah, which will be seven
N-
thirty, 7:30 here, EST.
7:30 p.m.
No, no, 10:30 or 7:30? 9 a.m.,
9 a.m. will
correct?
be 10:30 p.m.
10:30 p.m. Yeah,
9 a.m. will be
10:30
Oh,
10:30 p.m.
that
It will
will
be
be
too
p.m.
late,
that
right?
will be again
I
Yeah,
mean,
yeah that
too
will be
late.
very
Yeah.
late for
4 hours
you.
means like,
Yeah.
yeah.
So 4 hours is too much, sir. Even the 2 hours is enough. 2 to 4 hours. Saturday, Sunday.
Because general this course is 20 hours. Okay, total. So if I take
Okay.
every Saturday, because Sundays I need one day because it's a very hectic schedule mine. So I need at least one day off. I generally do that. Um, so if I take only Saturdays, let's say 3 hours, we can plan something like that. Because this time this course is we are not considering like how many audience we have. Even we have two, three, we will do it because we need this recordings which we are going to make as a standardized recording. So very flexible. Okay, this time the batch is very flexible, even the timings. So what I want to say is like let's say EST. Let me see what's the EST time. Let's say 3 hours. What is the about three? What about 3 hours?
Yeah, I am fine. Just
So what to
Let's
what
let's
time?
Yeah.
say I
At,
start.
So if it is
Yeah,
your
let's
Saturday
say
morning, if it is your Saturday morning, then it will be Friday night for us.
yep.
correct.
Yeah.
Yeah, yeah,
That would be fine, I think so. Like, I mean, 3 hours will be a lot, but like, again, we can try and see for one session, and if
yeah.
it works, then we can continue.
Because otherwise, then I need to take it maybe in the evening. So it will be early morning for you all.
Uh, okay, your evening, right?
Like, so for
Uh,
example, if I take it around 8:30 p.m. or let's say 5:30 p.m. or 6:30, yeah, something like that. 6:30
6:30,
p.m.
8 to 9 will work for us during weekdays. I mean, if it is 6:30 p.m., it will be
Yeah,
8 a.m. for us. 8 to 9 will
okay.
work. I mean, is it during the weekdays, or like, are you saying
Weekend, weekend,
it? Oh,
weekend.
weekend. Yeah, 8 a.m. Yeah, that would work, I think so. But again,
How many hours from 8 a.m.?
yeah, I would say like 2.5 hours, because we get
Yeah,
exhausted, I
okay.
think so, getting more
Uh,
information at the same time. Yeah.
Sir, I'll be
Okay,
available
because
until
see,
9:30 only, 1.5 hour on Saturday from 8.
oh,
If you are going to
okay.
start from, yeah.
Uh-huh. Yeah, so okay, then we can keep it then because Sundays I won't be there. So that's what my question. Because if we keep it only 1.5 hours, then it will take 20 weeks around to complete
Yeah.
this course, because it is a very long wait
Mhm.
which you will do, right? So which is not required. Uh, what about 8 to 10?
So is it
Like
morning or what time?
it,
EST
yeah,
time
it
in
will be
morning?
6:30 to 8:30. I meant my 6:30. So yours it will be 8 a.m. to 10 a.m.
Weekends?
Yeah,
Yeah,
weekend,
fine.
yes.
Yeah, I'm fine. I'm fine with it.
Okay,
Yeah, fine.
weekend 8 a.m. to 10 a.m. So that's why that's what I was asking. Okay, weekend till what time you can? Can you do it till 11 a.m.? 8 to 11?
I'm fine
Now
for
the
any time. I'm fine for any time
okay,
in
So
weekends.
I can attend until
because
10, sir, because I have to go out actually because my daughter do some extra
oh,
activities
okay,
learning, so I'll have to drop her.
oh,
Yeah.
okay. Yeah, okay. Then let's plan. Let's say 6:30 to 8:30. So 2 hours. When then if we when so okay, some Sundays also we can plan randomly. I will not say which one, but some random Sundays we can plan as per the schedule, as per the like how the availability. But mainly it will be Saturdays. So 6:30 p.m. to 8:30 p.m. Right? Okay. So yeah, then we can do that. Okay, I don't have any issue because I see like most of you are from uh, ESTRs, and also I'll have a discussion with Kumar also regarding this, because they what's their take on this, like for this course to get extended so long. Um, and final I will inform by tomorrow. Okay,
Okay.
yeah, that final timing.
It
Okay,
will take
so any other
almost 10
question?
weeks, right? Vishnu, it
Correct.
will take,
Yes.
yeah. Okay.
Yeah. True.
Yeah.
Yeah. So that's why I was like, no, it's not about my thing. For me, it's
Yeah.
okay, fine.
Yeah.
But the problem
Weekdays,
is,
yeah. Yeah. I know, like weekdays, sometimes, I mean, we can attend. I mean, myself, I can attend weekdays like this time is okay for
okay,
me. So, I mean, sometimes if I don't attend, I can do the recordings, but 10 weeks, if it is okay for everyone, then that's okay. Uh, I
okay.
mean,
So
if we are taking
Sir,
weekends,
sir,
yeah.
we can do one thing, one suggestion. So,
yeah,
because from Monday to Friday, we can
uh,
opt any 2 days, correct? So you can schedule the training in the same on the same time that we have right now, correct? 2 days,
okay, yes.
and one and
Hmm.
weekend Saturday for 2 hours. In that way, at least we can have 4 hours of training, correct?
Yeah, that is
Yeah.
also good only. So,
Yeah.
what I can do is same time we can keep maybe 2 days, like let's say Wednesday. Uh, okay, let's do one thing. We can keep it Wednesday, Tuesdays and Thursdays. Okay, is it okay? Tuesday
Yeah,
and Thursday,
yeah.
right? So Tuesday and Thursday we can keep 1 hour sessions. Okay, at the same time what we started today. So it will be, I think, 10:30 a.m. for you now. Is it?
Yeah.
11 a.m. around, right? Actually, what I can do is even I can start a bit early, like maybe 7:30 p.m. my time. So it will be 9 a.m. your time. 9 a.m. is it okay?
So,
Weekdays?
uh, so 9 a.m. or 9 to 10, always we have a meeting. So it's difficult
Oh,
because the
okay,
start of work, actually start of work. So in the morning we have the scrum
okay,
meeting
Yeah,
and everything.
9 a.m. it doesn't work like that.
Yeah.
okay. Then
Yeah,
that's
we
fine.
have
Then we
stand-up
will keep the
calls and
same time.
stuff.
We'll keep the same time. We'll keep every Tuesday,
Uh-huh.
Thursday, and Saturday. Saturday 2 hours. But the
Yeah, I'm
Saturday
fine.
timing will be, yeah, Saturday timing will be 6:30 p.m. my time. So it will be 8 a.m.
Yeah.
for you all, right? Okay. Okay. For now, let's
Yeah.
plan this. Okay. Then let's finalize
Mhm.
once, yeah, everyone is okay with it. Okay.
Yeah.
Right. So let's continue. Any other question? Okay. One is the timings. That's we will plan out. The next thing, anything like any doubts on the course or
So, so
something
how
like.
So,
we are going to complete the practical part actually, apart from theoretical. So,
So practically is mainly the tool. Okay. So the
yeah.
tool, whatever I'm doing, either you can go and do it after I do, by seeing the videos, or else what you need to do is you can sit with your laptop also. I prefer that one. Okay, like you all sit with the laptop and do with me also, because in that case, because later on when you send me a screenshot through WhatsApp and it's difficult to solve the issue. Okay, so better do it with me itself. When we do some creating some machines, or when we are deploying some Kubernetes and all, if you do with me itself, it will be good. So that's preferable. And yeah, so hands-on will be mainly the tool. Okay, mainly the tool, Gremlin and Chaos Toolkit. And we have our own application. I meant we have an application to test, which is basically a microservices-based application on which we will be running these experiments. Any other question?
No, no, sir.
Okay, right. So
Vishnu, I have
let's,
a
yeah,
question. I'm sorry. Yeah,
okay,
you said like I mean Gremlins like we can integrate with CI/CD pipeline, right?
correct.
So
Yes,
I mean, you were talking about Jenkins. So, but like
yeah.
we are using Neoload and we are planning to move to GitHub. Like earlier, we thought of Jenkins, but like
Mm,
a whole company wants to move into GitHub. So um,
okay.
we can integrate, right? And I mean Gremlins. And is there any way like you could give us like I mean give some instructions during the course, like
For
how
Neoload,
we can? Yeah, I mean for Neoload and GitHub integration into CI/CD pipeline, and also Gremlins if
yeah.
anything needs to be
Yeah.
integrated.
I'm not sure if I will be able to cover that GitHub Jenkins integration in this course, because it's little might take time. But
Uh-huh.
what I can do is, anyways, Jenkins I will be covering, right? So whatever is
Yeah.
remaining from the integration side, I can maybe give a quick light on that, and also
Okay,
little
sure.
materials.
Yeah.
Maybe you
Mm-hmm.
can go through those, but it will be very similar. The integration will be very similar. It won't be
Similar.
that
Okay.
difficult. It's mainly the files, like
YAML.
for example
YAML
the
file.
Terraform. Yeah,
Oh,
yeah. So
okay.
those,
Yeah.
yeah, uh,
Um,
yeah. That we can plan. Not an issue.
yeah. Thank you.
Anything else? Yeah. Any other question? Anyone? Okay. Yeah, so this module one is an introductory module, where we'll be giving a small introduction on the chaos engineering. What is chaos engineering, and the principles of chaos engineering, what are the activities performed by a chaos engineer and all. And we will try to see, like, even we'll try to understand, like, what all you need to take care when you're planning your first experiment, and all those, we will try to see here. Yeah. So now the main question is, like, why what is the requirement, like why does why is this chaos engineering required, right? So this question comes into mind, and what gave rise to this chaos engineering? Because the, already we have a lot of traditional testings, right, available, but what is this extra requirement of chaos engineering which is now popping up everywhere? Okay, so what's the main fundamental reason why this is happening? So one is the rise of the complex distributed systems. So anyone, can you what do we mean by distributed systems? Already working on distributed systems, or anyone of you, or you're still on? Right.
Distributed system is like master slave, right?
So basically, see, nowadays you would have heard this lot of this jargon called microservices, cloud. So all those cloud architecture with microservices are called basically the distributed systems. Now, what is this distributed systems is generally like? See, now for example, when you were creating an application initially, let's say for example you were using Java, but nowadays for each that application you can use multiple languages. Some used Go, Java, like they use multiple languages for multiple services, okay, and they all get integrated into one application. So that's how the distributed systems work, okay. They are very complex because they work on different softwares, different languages, all communicating with each other, okay, through APIs and all. So that's how a distributed system is, okay. It's a like it's, and the locations also, it's multi-zone because of the cloud and all, okay. So that's why the complexity has increased, and that has led to problems like outages, incidents and all. Because see, when you are developing some application, you will never develop it with a bug, okay. Always the um, uh, what we will think is, or the developers will think is, uh, there won't be any issue there, right? But what is happening is, when these are integrated, after the integration, when it goes to production, there are multiple issues which are happening in production, okay, and the application crashes. Now this application crash can be anything, okay, maybe some performance or some functional, okay, but the issues which are coming up due to the chaotic nature of the application, that's what we are focusing on, okay, as a chaos engineering, as a domain, okay. So that we will clearly see some examples. That time it will be clear what all cases we are looking into, okay. But for now, it's basically for the distributed systems, because more the systems became complex, the uncovering those potential issues which will come up became complex, okay, and that led to the rise of chaos engineering. And it's like a vaccine, okay. So basically, why do we have a vaccine? Is it to cure the disease or a precaution? Hello.
Precaution.
Correct. It's a precaution, right? So similar to that, this chaos engineering is also a precautionary measure, not a cure. Okay, so that you can cure some application from its disease. No, it from bug. But basically, it's like a vaccine. Okay, before any outage or incident happens, you need to recreate, or better not recreate, to create. You need to create those incidents, simulate those incidents, outages, and you need to find the issue. What's the issue in that application which is creating that issue, that outage or incident, and then you will solve it, so that in production that application's outages won't happen. Okay, now like we are speaking about these outages, like are the outages very expensive? Anyone, any guess? Or is it okay, like, okay, so my application goes down for 5 minutes, that's fine?
It depends, but generally it's expensive.
Correct. So see, now for example, just a year back or two, Amazon had went down for around 10 minutes, okay, and the dollar loss which they faced is around 10 to 20 million dollars, okay. So in 10 minutes, okay. So now if you see the outage for, okay, Amazon is a bigger company. Now let's compare with Netflix or some companies, like there are a lot of outages happening, okay, around, but people are living with it because it's an expected, as per the SLA 99% or something, they keep an SLA for the outages and incidents. Now it's under the SLA, okay, they have to, but it's not at all preferable, because this much loss, but and it's not only the loss of money, okay, it's also the loss of a goodwill, right? If a customer is coming first time to Amazon and he's facing that issue, he might not return, okay. It's a lifetime customer value that they are losing, right, from that. So that important chaos engineering is, okay, because it is targeting directly that customer experience side, okay, and also the business revenue. Now that's how the return on investment is generated by chaos engineering, because what you need to do is you are reducing the outages. In the sense, what you are reducing the cost, right? Because the loss or the customer goodwill, you are protecting all those. So that important the chaos engineering is. Now if you speak about the history of chaos engineering, okay, uh, initially chaos engineering was started by Netflix, okay. Like what was happening is, Netflix was moving into cloud. So when they were moving on to cloud, especially like they were moving on to AWS, okay. So they were moving on to distributed systems, they were implementing cloud services. So they had to, like, they needed a means to test those systems, okay, which they found out they can't do using traditional testing methods. So they created a tool called Chaos Monkey. Now, this Chaos Monkey is a tool which is very limited in the like, it was a very primitive tool created around 5 6 years back by Netflix. Now, this Chaos Monkey doesn't have much of a functionality. Okay, it can provide only one attack, and that way, okay, it is. So Chaos Monkey was not that um, efficient. So with time, they created lot of other tools like Chaos Kong, Chaos Gorilla, and all of them they kept a name called Simian Army. Now, what happened was, after few years, they what they did, Netflix did, is they released this tool on GitHub, the Chaos Monkey on GitHub. So everyone was able to use that. Now they start, like, other companies also started applying this into their organization, and this gave rise to sudden boom in chaos engineering. Okay, and different tools were developed as per the requirement, like chaos blade, chaos then chaos mesh, then we have chaos toolkit, gremlin. Okay, now this gremlin was created by a guy who was working in Netflix, okay, who was the brain behind this chaos monkey and all. So the gremlin's root is lying in the Netflix. Okay, right. Now let's try to understand what is chaos engineering. Okay, so chaos engineering is a discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So we need to now uh, clearly visualize this. Okay. Now chaos engineering is a discipline of experimenting. Now why are we saying experimenting and not testing? Any guess, anyone? Like, what's the difference between test and an experiment?
For test, we have the expected. We know what we are looking for. But for
Correct.
experiment, that may fail or pass actually. So accordingly, we'll have to take decision.
Correct. Exactly. Okay. So experimenting is more sort of, you don't have the expected outcome. Okay. What you're expecting. Okay. Anything can come. Okay. The result could be anything. So that's why in chaos engineering, when you run an experiment, you don't have what is your expected outcome from it. Okay. You only have the goal where you need to reach, but you don't know what's the expected outcome of what you're running. So that's why it's an experimenting. So whenever we say in chaos engineering, we never use the word testing, it will be experimenting. Okay, or experiment for test, experimenting for testing, and in that way. Okay, now that is the first keyword, right? Next is on a system in order to build confidence. Now why are we saying build confidence, right? How chaos engineering will add confidence to the system? Anyone, any guess? Now, if my system is very reliable, how will that indirectly add confidence to my system? Like, what are those confidence parameters which will increase if a system is reliable? Okay, so see, now let's say I have an application which is now currently using Java. Okay, now I want to upgrade it to, let's say, Go programming. My architect is saying, okay, Java is little slow, let's go for Go. Okay, due to some recommendation, we want to shift to Go. Now, if my client says, okay, will I be able to like, what will be the problems which I will face due to this migration, like Java to Go? Can I test it, or can I visualize it? What all the issues will be if I go from Java to Go in the production? Now, if I have some way to do it, like for showing my client, okay, we can go to Go programming from Java easily by using chaos engineering. Okay, I meant, like, by using chaos engineering, you can easily experiment it. Okay, so will that create confidence in the client to go for the Go programming? Uh, Getting my point? So basically, what chaos engineering will do is it will add confidence in incremental process also. Like you can easily like first of all your application confidence is there, like your customers will not face any issue, that confidence will improve, okay, with the time using chaos engineering. Second is you can easily deploy new technologies into your application with the use of chaos engineering, okay, because you get more confidence in apply the agile way, okay, because you are able to test everything before you put it in production. Okay, so that's why. So that's how you increase the confidence. Then the next is to withstand turbulent conditions in turbulent condition. Let's go to this keyword last, production. Okay. So next is withstand turbulent conditions. Now, my question to all of you is, what do you think will be the main difference between a failover testing and chaos engineering? Anyone heard about failover testing?
Yes,
Yeah,
sir.
So
So
what do you
we
think? Yeah,
we stop
from
intentionally.
what
We
I said,
stop one of the servers, few of the server, just to ensure that it's route to the other server. Or if we
correct.
stop the data
Hmm,
center, one of the data center, whether it's going to the another data center backup, the alternate one.
correct,
So this type of testing
correct.
we
So
do.
yes, yes. So that's a failover testing. Now, how if someone asks you, okay, what is the difference between chaos engineering and failover testing? Because there also we are killing the pods and all, then we are trying to understand how the microservices will react or how the microservices will respond to that. Okay. But so what's the main difference? So main difference is in failover testing, what we are interested in is like how well your system is able to withstand the failure, right? The keyword there is withstand. But in chaos engineering, we are not much worried about withstanding alone. Okay. What we are worried about is how well your system will recover also. Clear? Like not only withstand, one is withstand. Okay, it's good if our system is withstanding. But if it fails, it has to recover. That is the main thing which we are interested in. Recovery is what is the first important objective of chaos engineering. Second is obviously user experience. User experience, like how your user is facing this issue. Okay, we have to minimize that. We have to minimize that heat over the user as much as possible. So these are the two things which chaos engineering focuses on. Okay, one is recovery and the user experience. And last keyword is production. Now, what's the production? Why we are saying it production? See, whenever you are doing chaos engineering, the main thing what always you keep in mind is how will the application behave in production. Now, why am I saying production? See, whenever you are testing in any testing, okay, generally most of the things will be mock, but all the real thing will really happen in production, right? If you have a payment gateway or the real services, all like even the infrastructure, okay, we like for example if you say performance, okay, now performance will have common infrastructure like production, but won't be real services. If you go to the test environment, there might be real services, but the infrastructure is not same like production. So there is some difference between production and all this, okay. But so in due to this, what all you test in other environments, there might be difference when it comes to production, okay. There might be some noise or some issue which will creep in production due to these services or due to this integration or multiple places, okay, the problems can come in. So chaos engineering mainly focus on those problems, okay, and to avoid those problems in production. So that's why chaos engineering activities are generally performed in production environments also. It's not only the lower environments. Okay, so whenever we run some experiments, we run some experiments in production also to it's more sort of to check and all. We will see. Okay, as we progress in course, what is the procedure we execute the experiments and all. Okay, that's one way. Then coming to like we it's basically chaos engineering activities are always controlled and planned, okay. They're always like we it's not like some random experiment we do, okay. It's always controlled and planned. It's not that okay we are doing some chaos, so it's not planned or we have to plan, okay, but it will be a controlled and planned experiments. Now unpredictable failures we can prepare, right? Using chaos engineering we have to prepare for the unpredictable failures. As an engineer we need to think, okay, these are the failures which might occur, and we need to create the experiments around that. Okay, then preparing engineers for failure. Again, chaos engineering helps us to prepare our team for this failure. For example, let's say I have a payment microservice, or I have a order microservice. Now payment microservice team will be different, order microservice team will be different, the engineers. So let's say I perform an experiment on payment microservice. What will happen if my payment microservices fail? Okay, so one is the technical fix. Obviously, we will do some technical fixes so that that failure doesn't occur. Second is how will my engineers or how will my team react or respond to those issues, right? When if it really happens in production, who should be the real point of contact, who should be the owner of those incidents, the correct process, the flow. For experimenting all those also, you can use chaos engineering. Okay, not only for just running the experiment and fixing the technically, but fixing the process also. Then preparing for game days. Game days are nothing but, for now we'll go it in very deep. What is a game day? But for now, game days are nothing but where you run the test in production. Okay, so that day is called the game day. We'll see in detail what are game days, how we plan and all as we progress. Okay. Yeah. So let's do one thing. Let's stop it here for today. It's almost time. We will continue with the syllabus tomorrow. So we'll be seeing further on, like what are the a little bit on the more on chaos engineering, what it is and all, and also we'll be seeing Gremlin, how what is Gremlin and how what are the different options which you get in Gremlin, how you can use it and all those, the dashboard and all the introduction we will start tomorrow. So any question anyone till now?
Hi Vishnu. See, yeah, these
Yeah.
are all fine. So we have some FIS from Amazon, right? AWS, right? For this
Correct.
doing this chaos engineering. So
Yeah.
is it costly? So because if applications are already in part of a cloud or Azure, so why don't we use
Uh,
directly their products doing a chaos instead of
yeah, you can. You
Gremlin?
can. Yes. Yeah, yeah. So fault injection simulator you can, but the problem with it is pay per use. So for example, as per your application or as per what you use, you could be paying little higher. Okay. So maybe lower also. Like if you, it's all totally based on what your application is and your test cases, your experiments and all. But obviously, you if it's already on AWS and if you're okay with FIS, you can. But the problem with FIS is, again, it is a little bit complicated compared to Gremlin, which you'll understand. Okay, because Gremlin is more
Okay.
sort of a dashboard, GUI. You have a proper GUI, like a tool, like a chaos engineering tool. But FIS is more sort of it's like you need to know some command lines and all, some methods, okay, to run it. And there are some limitations. Like for example, you can't run it for, I think, 4 or 5 services are only supported by FIS, if I remember. Um, it's all the other services are not supported by FIS in AWS. Like for example, you can't test SNS, if I remember, and yeah, some 4 or 5 services. I'm not quickly recalling what are those, but only these 4 or 5 services are supported by FIS.
Okay. Okay. Thank you.
Yeah, yeah, yeah. Any other question, anyone, or else we can stop here for today. We can continue tomorrow, same time. Yeah, for this week, let's continue tomorrow also, like Friday, because this Saturday I'm not available. I have a small commitment. So Saturday sessions we will start from next week. Um, and so yeah, so tomorrow we will have a session same time just for this week. Okay, yeah. If no more question, let's stop here. And
Thanks, Vishnu.
yeah, have a good day, everyone. Thank you all.